Hello, hello. Are we live? Alright, welcome back to Advent of Syntran. This is day 12. Let's make a new directory. And let's get the input. I did look at the prompt for day 12 ahead of time. So this isn't my first time reading this. This is the test input. And we should be able to echo that. There it is. Let's get the real input too. I really need an automatic downloader. Like, I'm not competitive, but it's a non-trivial amount of tedious work just to save the input every day. Okay, so I have that. Let's take a glance at that. Yeah, and these are not huge. There are 1,000 lines, but each individual line, no particular line is very long. Got maybe like, I don't know, this is one of the longest ones I've seen, 20 characters, and then some numbers. I wonder if I can count the maximum number of question marks on a line. No, I don't think I can come up with a good regular expression for that. So this is 20 characters, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 question marks, and we know that 2 of these, no, 6 out of 14 are going to be in one state, and the remaining ones are going to be in another state. So basically you have dots or hashes, and then the question marks can be either a dot or a hash. And this tells you the grouping of the hashes. So if we did like every possible combination of 6 out of 14, what is that? This is called n choose k. This is the number of combinations. It's not permutations. You could solve this problem in terms of permutations, but combinations should be faster. Yeah, I don't know what this number is. So I think we can kind of brute force every combination and then check which combinations match the arrangements or not. So this is apparently the most complicated one in the test input because it has 10 possible arrangements. We know we have a group of 3 and a group of 2 and a group of 1. So this has to be the group of 3 hashes. And then at some point in the remaining question marks, we could have like a group of 2 hashes here, and then a gap, and then another single hash by itself. Because this means we have a group of 3 and a group of 2 and a group of 1 with at least one non-hash delimiter in between. So I think we can check every possible combination of, question marks that have a total of 6 hashes. We know that there are hashes here, so there are only 6 unknown positions. It's sort of like you can think of the question marks as a binary number. Like every question mark can be a 0 or a 1, but we don't have to check every binary number. We only have to check the binary numbers with the correct amount of 1s. So we know there are a total of 6 1s, and those are the only combinations we need to check. So I think that's how I'll approach this. Maybe there's a more clever way. Let's see. This is not an easy day. I thought yesterday was relatively easy. This is definitely harder. And what is an onsen, by the way? It's a Japanese thing. It's a hot spring. Okay. Today I learned. Okay, so what I'm going to need is a next combination algorithm. In last year's Advent of Code, I'm pretty sure I used a next permutation algorithm at some point, but this is different. These are combinations, not permutations. I was looking at something on my phone after I read this. Let me find that link, because the link that I looked at made sense to me. Can I find this? Yeah, I think this is the link that I was looking at. There we go. Yeah, see, this is like a nice short block of code. I can understand it. I like this resource. It's not like this where, first of all, there's a giant pop-up in the middle of my screen, and then they start with like a giant graph. They have like paragraphs and paragraphs leading up to the code. And then, what language even is this? Pseudocode. But like, this is really weird looking pseudocode with no indentation. This is probably basically the same thing, but, you know, this website gets right to the point, and I like that. And I could make a function that does this. I could start out with my first combination, which is a bunch of hashes to the far left as possible in the question marks. And then I could pass that to a function which returns the next combination. But I've learned my lesson that syntran is very prone to memory leaks, and I believe that happens just when you pass an array as an argument to a function, because then the array gets passed in by value, so a temp array is copied and created, and then when that function goes out of scope, that temp array never gets deallocated. So I know if I make a function for this, it's going to cause a memory leak. So to work around that, I'm just not going to have a function. This is going to be inlined in like my part 1 function. It's just going to be in the main body of my program. So what I need to do is I need to count the number of question marks. I need to get a vector of their positions. And then I need to fill those in with hashes and dots with every combination that meets the criteria of 6 hashes. We're looking for hashes, right? Yeah, so these groupings refer to the groupings of hashes. Like we have a group of 3 and a group of 2 and a group of 1. And this is, these are all 10 possible combinations for this line. I'm wondering if we can modify the next combination algorithm to just, you know, include the gaps and then narrow down the space of combinations. So to not check every combination, but only the combinations that meet the criteria of having the correct number of hashes and having the correct delimiters to separate the groups of hashes. I don't know, that might be too hard. We'll see how bad it is. Maybe I'll come up with something that's really slow. And if I can't figure out today, so be it. These problems are going to start getting hard, and I'm not going to figure out everything. I got like 44 out of 50 stars in last year's Advent of Code. So I think if I could get 40 stars this year, I would be satisfied. I'm not going to kill myself to try to get 100%. Wait. Where? This? Is this the test input? No. Yeah, I need the one with the question marks. I saved the wrong thing because this has no question marks. There we go, that's the right one. And now I'm echoing that. Let's open that up here too. Oh, and my stream window is not on top and my transparency is not fancy. I have a bunch of windows open in the background. There we go. Is this readable? Let's go a little bit more opaque. I think maybe I've been too transparent and my code is hard to read, but my background looks cool. And then I want this to stay on top no matter what. There we go. And I need this to stay on top too, behind my webcam, so that I can't see what you can't see. That did not work. There we go. Okay, this is yesterday. So first, I want to count the number of question marks, and then I'll allocate an array of all of their positions. An index array of all of their positions. And I think we only need to work with one string at a time. That should count the question marks in each line. So we have 3 here, 5 here. I assume that's 8. I'm not actually going to check, but yeah, those look correct, I think. I'm not going to check every one of them. And now I want to save the positions, or the indices of every question mark. So I'll initialize it to -1. That way, if I try to index an array by this, it will be out of bounds, and there's not actually bounds checking, so it probably won't help me at all. But if at some point I have a debug interpreter which does bound checking, this would trigger a bound check error if I did anything wrong later. And we're just going to repeat this loop, but instead of counting, now we're going to save the position. So this needs to be more than 1 line. And then we can, now we have the indices of every question mark. All right, that's already declared. Okay, so we have a question mark at 0 and 4, 5, 6, 7, 8, 9, 10, 11. Let's spot check another one. So 0, 1, and 2, 0, 1, and 2, and 4, 5, 1, 2, 3, 4, 5, 6, Okay, that looks roughly correct. Now, basically at each one of these positions for this line, we're working one line at a time. So let me print a line break. So this is a little easier to read. So this is the final line. We're going to fill in every one of these positions with either a dot or a question mark. And the rule is that this is okay. I'm actually parsing the integers too and checking if those are question marks. It's fine. I guess it would be a little bit more efficient if I stopped here. Like I could split the string and then by a space as a delimiter and then only check for question marks up to here. That's just going to be more code, but it's not going to be much more performant. So I don't think there's any point to doing that because we're never going to have a question mark or a dot or a hash in the trailing part of the line. But I do need to split and then read these integers. So these integers sum up to 6. 3 plus 2 plus 1 is 6. So I'm going to fill in these positions with a combination of 6 hashes and the rest dots. And I'm going to try every combination and then check if the grouping is correct. But to get the numbers, we have to split at some point. Or I can use my function which splits and parses integers at the same time, and I can treat all of the stuff at the beginning of the line as a delimiter so that it gets ignored. And I forget what that function is. It's like read I delim or something like that. No, it's parse I delim. That should really be delims because there's more than one, but I have a bunch of other code for the previous days that uses this, so I'm not going to bother changing it right now. Parse, not read. Parse I 32-bit integers should be fine. So it's the string, and then what are our delimiters? We could have a dot or a hash or a question because I want to ignore everything at the beginning of the line. We could have a space and commas. I think that should do it. So like for this line, we should get 3, 2, 1 as the groups. And there we have 3, 2, 1. And for this line, it's 1, 6, 5. All of those got parsed correctly, it seems. Need a variable which is the size of the groups. Yeah. I could just call size, but it'll be nice to have this saved as a variable, I think. We're just summing this array, but I don't even have a sum function, so so here 3 plus 2 plus 1 is 6. Here the sum of this thing is 12. Yeah, that's right. Okay. Now, we're going to make a combination of dots and hashes, and the total number of hashes has to be this. So this is like n choose k. You have n is the number of question marks. So it's like nq choose n hash. This is mathematical terminology for like the number of combinations. I think I had this open and then I closed it. It's called n. What are you talking about, Chrome? N choose k? I don't know what that pop-up was. Yeah, so it's this expression. It's n factorial over k factorial times n minus k factorial. And it's also the numbers in Pascal's triangle. I know this is hidden behind my windows, but you can see part of Pascal's triangle here. Yeah, so this is the number of combinations that we'll have to check. But I don't really care what the number is. I'm going to generate them in a while loop. So the first combination is... For this one, we need a total of 6 hashes, so I'm going to fill this in with a hash, and I'm going to fill in these 5 with a hash. So I'm just going to group the hashes as far to the left as possible. I don't care about these because these are knowns. I'm only checking the unknowns. So we're going to group the hashes as far left as possible, so basically that's going to be a hash at 0, 1, 2, 3, 4, and 5. That's a total of 6 hashes. And then from there, we're going to generate the next combination. Is this consistent with the algorithm that I'm going to copy? Yeah, the first combination is just going to be 1 through k. That means everything to the far left is possible. I don't really have a string repetition. Can I? I don't think I can do this. I think this would work on Python. You can like multiply a string by a number, by an integer to repeat it. Pretty sure I don't have this. And yeah, NQ is the number of question marks. So this doesn't work. Yeah, that's not allowed. I need like a repeat string function. Does it make a difference whether I have a vector of characters or a string? Because those are 2 different types in syntran. Because if I make it a vector of characters, I could do this. I had a utils function that did something similar. I can't remember what it was. Okay, reversing a string. So in the case of reversing a string, like I allocate it up front but I can do that by just assigning it to the input string. So that doesn't help. And the same thing for this, where I remove all occurrences of a character. I can pre-allocate by assigning it to the input string, but I don't really have an input string. But I could hack it. What I can do, I know that the whole line is longer than the total number of question marks, because it has to be. So I could do... Yeah, what I'm trying to avoid is, initializing this to the empty string and then doing a loop and concatenating it to itself. I'll do this just to demo it. Do I have string plus equals? I'm not sure if I do. Dot. So this should be all dots so far. I don't know if this will work. Okay, so that did work. And we have, but NQ is 9. Yeah, so we have 9 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9. But this is not good because it's repeatedly concatenating one character at a time to a string. So every time this gets evaluated, it has to allocate a whole new string and pad this onto the end. And that's not really great from a performance perspective. It might cause a memory leak, I'm not really sure. But either way, I would like to avoid this, so I can cheat by doing the input line just 0 up to NQ. And then this is going to have like the first NQ characters of the line, but the nice thing is it allocates the string in one shot. So I think what I need in syntran is a string allocation function. And here we go, we have 9 characters now. So this only works because I already have a string that's at least this length. And now I want to fill this up with all hashes on the left and then dots for the rest of the line. The number of hashes is going to be n hash. So and this was concatenating, so that's inefficient. But this does not have to reallocate a string. This just sets one character within an already allocated string, so this is efficient. And then the rest of the line has to be dots. So n hash through NQ. And that's the first combination. So we should have a bunch of hashes and then a bunch of dots. We should have 6 hashes and then 3 dots because the total length is 9. So 6 hashes and 3 dots. Now we need to iterate through every possible combination like this. So next we're going to have 5 hashes, then a dot here, and then a hash here. That's the next combination. And then we'll have like a group of 2 hashes at the end and a dot right before that. And I don't know how many there will be. There are going to be at least 10, right? Because we know we know that there are 10 combinations that meet the grouping criteria, and I'm going to loop through more than 10. I'm also going to iterate over the ones that don't meet the grouping criteria. And then after I generate every combination, I'm going to filter them down to just the ones that meet the grouping criteria. There's probably some clever way that you could only generate these and not have to do any filtering. Maybe part 2 is going to be super difficult, and that's the only way that you can do this in like less than an hour of CPU time or something crazy. But we'll see. Maybe I can only get part 1 today. So we're going to iterate through combinations. The while loop is tricky because I want to iterate until I get the last combo. And I don't really know what the last combo is. The last combo is like the opposite of this. So instead of having all the hashes on the left, this is the first combo. The last combo is going to have all the hashes on the right. I don't know how I'm going to set this condition, so for now I'm just going to set it after the first loop iteration. So this just prints this, and then it prints the same thing again. Now we get to implement this algorithm. And I'm not going to make a function because I'm 99% sure this will cause a memory leak. So I'm just going to inline it. And I have to convert this from whatever language this is into syntran. K is the size of the vector. So that's NQ. It's NQ because NQ choose N hash. So they normally say, oh no, it's N hash. So normally this is called N choose K. So for me, K is N hash. So K is N hash. N is NQ. I don't really have an A. A is like another index array. So A would be the indices of the hashes within my combo string. So for this first combo, it's 0, 1, 2, 3, 4, 5. Right? Like this is 1 based, so it's 1 through K, but for me it's 0 through K minus 1 because syntran uses 0 based arrays. So I guess, do I need an index array? Yeah, maybe I do need an index array. So let me pre-allocate that. That's going to be 0 through N hash, right? Because here you can basically see the index array. So the indices of the hashes within my combo string is exactly this, because we're iterating through those and we're setting them to hashes. And initially this is for the first combo. A is just A. Basically, I'm reading through this function and renaming everything in terms of my variables. Because I don't have a function, I'm just inlining this to avoid memory leaks, or to work around memory leaks. And a.size is n hash. Yeah. So this is equal to this. That makes sense. Then we just have some loops. I think, yeah, I can just use I. I can just use I and J because I'm not using those for anything else in this scope yet. We have I up here, but as soon as this loop is finished, I is out of scope. And these booleans are basically last. Well, no, these are not last. So true means we have a next combo, we're not done yet. False means that's the last combo. So this boolean is the opposite of last. Okay. I think we can go line by line now. So let k equals n hash. This is just the initial value of k. For I, oh, we have a negative step loop. I can't do negative step loops. So we're going to have I, and then we're going to calculate I from this thing. I need to be careful with these off by one errors to make sure I go through every combination without skipping any or without going too far past. Hey, Kelly. I have to feed Callie at some point, but she's hungry already. She's always hungry before mealtime. Callie, are you going to be rude like you were last night? You started to bite me last night while I was streaming. That wasn't very nice. You want to say hi to Twitch? Or do you just want to step on my keyboard? I have to concentrate, Callie, because this problem is hard. It's not like yesterday's easy problem. Are you gonna let me do this? I think she might come back. Okay, so what am I looping through? I can't do negative step loops, so I'm gonna loop through these in the other order. 0, is it 0 through k? Yeah, I think it's 0 through k, because this is not inclusive of the upper bound, and this starts at k minus 1. Callie, I'm sorry, you can't be up here. This is going to be a recurring incident. And I don't have negative step loops, so now I need to calculate I from my actual loop iterator. And it's going to be k minus I. Yeah. Minus 1. So for the final case, that's going to be k minus, this is confusing. So for the final iteration through the loop, it's going to be k minus 1 minus 1, which is the k's cancel out and the 1's cancel out, so that's 0. And that's exactly what I want because this goes down until I equals 0. So I think this is correct, but I might be off by 1. N is NQ minus K plus I plus 1. That's a terrible expression. Then Callie. AI is incremented. I don't have a plus plus operator. I probably will add one eventually. You know, in Rust, they are philosophically against the existence of the plus plus operator because they say it's too confusing with the evaluation order. Like, is it a prefix plus plus or is it a postfix plus plus? It makes the language simpler if they just leave it out. But I don't know if I agree with that. I kind of like the syntactic sugar. And if you know what you're doing, you can use it correctly. I don't know. Maybe they're right. Maybe it's just an opportunity for bugs. Oh, thank God, we don't have another backwards loop. So for j in I plus 1 through k, aj equals aj minus 1 plus 1. This is just this line verbatim. I don't have to do any syntactic transformation. It's just exactly the same in syntran as, is this C? I think it's basically C, but they're using std. Or C++, I mean, not C. So is that the index array? And we want to set this Boolean. So here it's false. It's just initialized to false, so we don't have to set it on this line. Oh, but this returns. So basically there's an else clause here. And if we get to the else clause, no. Yeah, so there's an else clause here, and if we get to the else clause, last becomes true. And I guess I want to print the index array too, because I haven't set combo yet. The next step will be setting the combo string from the index array A. But let's see if this is right. That is not right. That is not right. What is up with this code? Is this code right? Did I translate it wrong? Consider our current combination and find the rightmost element that has not yet reached its highest possible value. And you increment that by 1. And then assign the lowest valid value to all subsequent elements. So the next combo After this, with the hashes as far left as possible, this is the first combo. The next combo should have hashes here, and then we should have a dot here, and then we should have a hash. But why is it just shifting everything to the right? So we should have 0, 1, 2, 3, 4, 6. That should be the next combo. And we set the 6, but then all of these are wrong. Oh. Is this assuming that it's one-based indexing? Maybe. Because if that's the case, we can't have a 0 here, so it sets it to 1 instead of 0. So I think this line is wrong, and we just don't want the +1. Why does this iterate like that? Maybe it's this line that I have wrong. What do I have wrong? I just commented out this. That's not right either. Why do we iterate all the way down? Is this also off by 1? Maybe I should not have picked this website. I don't see why I'm iterating through all of the I's. NQ. NQ. N should be NQ. Let's try this again. That's worse. Yeah, we should not be getting a 9 here. This should be the last combo. And we're not getting a bunch of combos in the middle. So that's bad. But we shouldn't be going to 9. Did I do this in the wrong direction? Should that just not have a +1? So that stops at 8 now. That's a good sign. Oh, we have to return early. Right, because this has an early return, and I don't have early returns in syntran. So this needs to be a while loop and not a for loop. Because with a while loop, I can break out of that at least. I don't have an explicit break statement. I don't have an early return. I don't have like an abort or a system exit or anything like that. But with a while loop, I can change the while condition. And then since I've transformed this into a while loop, I have to increment this at the end manually. And I need a boolean to break out early. Let's call it found when we find the next combo. So if that happens, we break early. And yeah, I think this is okay. I don't think we need to set found here as well. Yeah, I don't think it matters. And maybe this was right originally. I don't know. Let's find out. Yeah, so that's still, this is better, but it's still not quite right. So n minus k plus I plus 1, and then this for loop. Let's try this for loop again. I don't know if I needed to change this. Wait. I plus 1 through k. No, this was the original one. So this stops at 8. That's good. This is called random walk programming. You just try random things until it works. Yeah, that's definitely worse. This is Syntran. This is my own language. Welcome to the stream, Suiting Ranger. Well, it's not a very good language. I was following along with a YouTube playlist called How to Build a Compiler or How to Make a Compiler. So if you go here, this is the interpreter for my language. It's an interpreted language. It's based on this YouTube series called Building a Compiler. Hey, Kelly. So I watched at least 10 of these episodes. Yeah, so I started out just following this YouTube playlist and basically translating it into another language. So it wasn't super original. I have to get my cat out of here. She's getting mean for no good reason. Kelly, I'm streaming. She wants to bite me. Okay, so I will be back in a minute. Come on, Kelly. All right, I'm back. Sorry about that. I am working on Advent of Code. I don't know if you've heard of that. It's a series of programming puzzles. They come out every day in December, so every day there's a new puzzle until Christmas. So today's problem is we're given all of these lines, and they're either hashes or dots, and they also give you these groupings. So this means there's a grouping of one hash and a group of one hash and a group of three hashes. So just like this, with at least one non-hash delimiter in between. But they don't give you this. They give you a bunch of question marks. So they actually give you this line, and you have to figure out which question marks are hashes and which question marks are dots. So I need to loop through every possible combination and figure out which ones meet these grouping criteria. And I'm struggling on generating the next combination. Maybe this website is just not very good. Stack Overflow is trustworthy. Again, this is a one-based indexing. I think part of my struggle is that maybe this is an indexing for one-based arrays, and my language is zero-based. So this might not be any better. I've done next permutation before, but that's different from next combination. This description makes sense, but I'm struggling with the code. So what if I ignore this and try to just translate this into code? All subsequent elements. So we should do I equals 5 and then stop. This shouldn't iterate any more than that. But it does an extra iteration, and that's not right. I did not think copying and pasting code from the internet would be this hard. And this should stop at 8 because we should never have an index greater than 8 because of the size of this combination. I think this else clause is wrong. So if we get here and we haven't found anything, then we set... Maybe I had this right all along, but I was just breaking out of the outer loop early. So if we get here, because this has early returns, and my language doesn't have early returns, so I need to translate these into while loops. If not found, then last equals true. That's worse. That is not right. But where should that... It should be outside of this loop. So I think I set this in the wrong place. That looks better. We still shouldn't have 9. Okay, so that's the first combination. That is the next. No, it isn't. We should have 0, 1, 2, 3, 4 instead of 5, and then 6. Three, 4, 5, 6, 7, 8. That should be the last combo. Did I get all of the combos in the middle? Yeah, that's still not right. That's an infinite loop. Wait. Why do I set that there? We've already set AI, so this is definitely not right. This looks right. I don't know what I changed. We have 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 6. Yeah, so we should keep incrementing this one until it gets to its max possible value. So once this gets to 8, we can't make this any more than 8 because that would overflow past the end of the array. So then we increment this instead. So we have 0, 1, 2, 3. Then we have a 5 instead of a 4. And then we set everything after this to the lowest possible value, so this becomes 6, which is 1 more than 5. This looks right. I think this might be right. I don't know what I changed since the last time I ran that. Maybe I just wasn't looking at it close enough. So what did we end up with? So this was from the website that I copied. They had a +1, but because I'm using zero-based indexing, zero-based arrays, I had to get rid of that +1. And then this line is the same as what I copied. So I think this is working. This is getting the next combo. Now, the next step is to check if this meets the grouping criteria. I think I have to form my string. Yeah, I want to set a combo string from this index array. So now that we have the combination index array, I want to set the combination string from the index array. This is just up to NQ. So that will set it to all dots, and then I want to put a hash at the positions indicated by this index array. So this will set everything to a dot, which is a little bit more aggressive than I need to be. And then this will put the hashes where the hashes need to be. So that looks like it worked. So this was the first combo, and then we should have a dot and then a hash. So that's the next combo. And then we keep moving this hash to the right until it's as far right as it can go. And then we're going to move the next to the last hash. So this moves the next to the last hash, and then it moves the last one as far left as it can again. So this is this almost like a big number addition? It's like when this rolls over, we change to the next digit, and then everything after that gets reset to 0. So it's almost like a big number +1 algorithm. Like if you had a big number and you were keeping track of digits and then carrying the digits, the logic would be sort of similar to this. So I think that looks right. Now we have to check which combos meet the matching criteria, and that is easy to do. So since we have the string, and I have this split function, which can split a string by a delimiter, what I can do is split this string using dots as a delimiter, and then check the length of every string that I get out of it. It might not be super efficient, and I think it's going to aggravate one of my memory leaks. So we'll see how well this scales, but I think logically, and if I had enough memory, it should work. Do I explain what I mean by a combo? Unknowns. So we're only going to check the combinations which have the correct total number of hashes. That's my strategy here. Grouping criteria. See, I already have something called groups. Maybe I'll just call it G. And we're going to split it using dots as a delimiter. Now, there are really two different criteria. First, let's look at the puzzle input so I can explain this. So first we have to have the correct number of groups. So this has 3 groups. Now if the length of the string vector that I get out of my split function doesn't have 3 groups, I can stop immediately. If it has 3 groups, I then have to check if each group is the correct length. So there should be a group of length 1, and a group of length 1, and a group of length 3 for this first line. So first we have to check if the size of the groups is correct. And if that's right, then we can check every subgroup. I really have too much output here to scroll through. But yeah, so this has a size of 3, so we're expecting 3 groups. I don't think I need to print every one of these things. I think I have a variable for this already. ng. ng is the size of the groups, so I can just use that instead. This should be a while loop because I can break early if I find one group that's the wrong length. while I less than the number of groups and all equal. So every group of this should equal the group sizes that were given. So they all have to be equal, and that's what this Boolean will keep track of. And this will be len g I equals groups I. Now, what is the actual answer that we're looking for? I think it's like the total number of possibilities. So if this is true, we're going to add 1 to something. So the number of possible arrangements, or the number of valid combinations, adding, yeah, we have to add all of these up. So if all equal, then sum gets incremented. And I think I initialized that. Yeah, I initialized that to 0. So let's see what this does. That did not compile, or it didn't parse technically. Split. Split has an underscore at the end. Just in case I make like a built-in function later. G is undeclared. I is undeclared. I just forgot to do a bunch of stuff. What? Oh. I have scoping, so all equals only exists inside of this scope, so I couldn't do it out here. 4. Well, that's not right. So, like, this should be valid, because the groups, I think, are 3, 2, 1 for the last 9. So this is 3, 2, 1. So I think this is a different one than what I just highlighted, but we have a group of 3, then a group of 2, and then a group of 1 with at least one non-hash delimiter in between each group. So I guess I didn't count those correctly. Let's see why. Which ones am I counting? Hey, I should just do the first line and then stop. Well, that's not valid. Why does it think that's a valid combo? Did I split this correctly? No. Does my split function not work? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. I think maybe my split function my split function doesn't work, and this is the first day that I noticed. Let's just do the first line. Let's not loop through every line of the file. Oh, okay. I forgot to count these. I forgot to count the known hashes. Okay, yeah. So I need like another level of indexing. So when I fill this in, this is not right. This is just filling in the unknowns, but I need to fill in the unknowns and then intersperse that with the knowns. So this is not right. Combo is going to start out as just the input string. And then we just have another level of indirection. So instead of combo AI, it's going to be combo IQs I. And I think that's all it is. So what is... Did I save that? I have to do the same thing up here because my first combo isn't right now. At the unknown. Unknown is hard to spell. So this is not right at all. It was close. I just need that extra level of indirection here. IQs is the index of the question marks. So Q is for question mark, S is for plural, I is for index. So this is the index of the question marks. These are the positions of the unknowns. That kind of worked. So that's the first combo. That's correct. So this is tricky because 113. Oh, man. I've made all kinds of mistakes. So like the total number of hashes, I also forgot to count these guys in the total number of hashes. So what have I counted? I've counted the question marks. This is really the number of unknown hashes. It's the number of hashes that we don't know the location of. No. This is the total. because this is the sum of these. So there's a group of 1 and a group of 1 and a group of 3, and that includes these. So this is the total number of hashes. But the number of combinations is really based on the number of unknown hashes. So where do I reference n hash? Because some of those aren't correct. So like the way I counted the question marks, I also have to count the number of known hashes, and then from that I can get the number of unknown hashes along with the number of total hashes. I want to rename this. Okay. So the number of unknown hashes is what I want to use for permutations. So this should really be unknown hash. Okay, let's see what that does. Yeah, I think I'm like overflowing some string or some array, and that's why we got this crazy stack trace here. And that still crashes. How is NQ 6? This just doesn't look right at all. How is that? Oh. Yeah, I counted the wrong thing here. I initialized it, but then the thing that I incremented wasn't what I wanted to increment. Okay, this seems better. So the number of question marks is 3. The total number of hashes, which we get by summing these numbers, is 5. So this is the total number of known and unknown hashes. We know where 3 of them are. We don't know where the other 2 are. any two of these question marks could be hashes. So this has the right number of total hashes, but it doesn't meet the grouping criteria. Oh. So if an unknown is not a hash, I don't really have to fill it in with anything. I can just hack the split function by splitting it with dots and questions as delimiters. But this still isn't right because I should be detecting some valid combos here. So we have the first combo. That's right. This is right. But this split is not right. So I did this at the wrong place. I have to check the combo before I get the next combo because I've never checked the first combo, so I have to do that here. So I can copy and or cut and paste this. And I think doing this is optional, but I do want to allocate it outside of the loop. It shouldn't matter, so I'll just leave it there. Okay, so we have that, and then we split it correctly. This is not right. This should not split like that. But if I split it like that, this should be a valid combo. So I have multiple bugs here. I'm not splitting this correctly into groups of hashes, and then I'm not detecting this as a valid grouping. So let's have a little unit test. Can I split this thing correctly? Is that how I split it? Question, then dot. Yeah, I did dot, then question. So that if I have a bug, that might matter. Dot, then question. Well, that's right. Am I like only printing G sometimes? split combo. So like this little unit test at the end is right. But I print the combo, I print A, then I print this stuff. I cannot make sense of my own logs. Printf debugging me is failing me right now. So the first combo. Where does this extra question mark come from? It shouldn't matter because I'm treating it as a delimiter either way. Yeah, so I don't want to print this stuff because I haven't actually set it yet. I've initialized the index array. This should be a valid combo. What are the lengths of these strings? So I think splitting is working. I was concerned that splitting wasn't working, but now this looks correct. But this should still get detected as a valid grouping because we have a group of 1, a group of 1, and a group of 3. Does the size match, at least? So this has a size match, that's good. Because we have 3 groups. Oh, I have this junk at the end. So, fuck it. I'm just gonna treat digits and commas as delimiters. Commas are delimiters and digit characters are delimiters. Yeah, I really should have like split the string by a space initially so that I have like the string and then the numbers, and then I don't have my numbers mixed in with the first part of the string, but I intentionally didn't do that because I was lazy, and now I have to continue being lazy. Okay, so again we have a size match, but I need a space as a delimiter too. There we go. Now we have one valid combo for the first line. Is that right for the first line? It has to be. Yeah, there can only be one. So there's one arrangement for the first line. Let's check the rest of the lines. What am I doing? I also have to feed my cat. She really wants her dinner. But I think we're pretty close here. So where's this while loop that I commented out? There's the closing bracket. Brace, I mean. We're crashing. Okay, well, I have to feed my cat before I figure this out. So, just in case anybody drops in, I will be right back. Alright, we're back. So why is this crashing? We're crashing on this line. Is that even in the input? Okay, I guess that's the third line. Well, that is a weird one. So the number of question marks, 1, 2, 3, 4, 5, 6, 7, 8. And the indices of those question marks are every other one. So 0, 2, 4, 6, 8, 10, 12, 14. Groups. Oh, 1, 3, 1, 6. That's just part of the input. So if we sum these, 1 plus 3 is 4, plus 1 is 5, plus 6 is 11. So we have 11 total hashes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That first combo looks good. And then why does that crash? Where does that crash? I have a bunch of junk in here that I want to clean up, but I don't just want to totally delete it. So I'm going to copy this to a backup file. And now I feel safe to start deleting, because this is like, it's hard to scroll through all of this. This really shouldn't be necessary. And like maybe this is crashing, so if it's not necessary, I want to delete it or at least comment it out. I thought split wasn't working, but it was working the whole time, so I added a unit test right there just to make sure. Callie is back in the room. I think she was less interested in dinner and more interested in just hanging out with me, but she's jealous that I'm streaming. Ooh, yeah, we got further than we got. We got to the end. Everything finished, and then this crashed. So there's some sort of terrible memory management bug here. I don't know how that happened, but it says 6, and 6 isn't right because what are there, like at least 10? Like one of the lines by itself has to have 10. So there should be 21 total arrangements. Which ones did we miss? So this, this allocates the string, and it might be better if I do that outside of the loop. Hey, Vision for All, welcome back. So this crashed at a different place now. Is this totally inconsistent? Yeah, so this is the line with a question mark at every other position. That seems to be the same. I don't know, maybe it's at least crashing consistently. Yeah, part 1 is proving difficult for me. I'm struggling a little bit here. Even if I finish part 1, I don't think I'll have time for part 2. I can work on these for about 2 hours on a weekday, and then I am just out of energy. What if I don't allocate this string out here and do it in here instead? It shouldn't make a difference. That's very weird. Let combo equals str. I might have a syntran bug. Because this is an, I think this is an evaluation time error. So there are various stages to interpreting in syntran. First, I read the source code file, then I lex everything into tokens, and then I parse the tokens into an abstract syntax tree. So that's like a parse time thing. And if you have any syntax errors, those should be caught during the parsing stage. And then after your whole file is parsed, then it goes through and evaluates everything. And this is an evaluation time error. And I don't really have good error messages for a lot of those. Why is this happening? I need to trace this to figure out where it's crashing and why. A. A should be okay. Let I'm getting confused. I can't even look at my own source code anymore. It says combo A equals. I might have a type problem for A. So yeah, it was crashing here because it prints A equals, and then instead of printing the value of A, it prints this error message, and it says, I can't convert A to a string for some reason. But A should just be a vector of integers, and why would it not be able to print that? N unknown hash is 4. Something funny is happening. Okay, so we printed the initial A. This is the first combination. It's just 0 through 3. Because it's all of the hashes as far left as possible. And that's the first combination. This indexing is not correct. Do I have this backwards? I think I might have these nested in the wrong order. Should it be like that? With A inside of IQs. IQs are the indices of all the question marks. A is my combination array. That's a little better, but I don't think that's the right answer. Oh, that's the right answer for the test input. Wow, that was tough. Okay, I guess let's try that on the real input. Yeah, that was really weird. Somehow, I don't know what happened that A was unprintable. Error handling is not always the best in syntran. The parse time error checking is okay, but the runtime error handling is terrible. So like if it tries to print this and it for some reason can't evaluate this or can't convert it to a string for printing, you just basically have nothing, you have no information to debug the problem. So this is why I recommend that nobody uses this language. Let's see what happens. This might also crash. I have no idea what's going to happen with the real input. It's very verbose. I could turn some of this logging off. I have no idea if this approach is good at all because I'm checking all of the combinations, even if they don't satisfy this grouping criteria. So there might simply be too many combinations to check in a reasonable amount of time. I think I at least want to turn off a lot of the logging. I can print the string. I can print some summary information, but I definitely don't need to print every combination. I don't need to do any printing inside of this while loop. Let's see what that does. Well, that's... yeah, this is not very fast. You can see it do one line, and then when... what are the numbers that I need to think about? It depends on the number of unknown hashes and the... I don't know. This is n choose k, and it's checking a lot of combinations. And what do we have, like 1,000 lines in the input? Am I in? I need to go to day 12. There are 1,000 lines. I want to print the line number that I'm on so I can judge this progress. I think, I mean, it's chugging along. It's not fast, but this should finish in less than an hour, I would guess. But I would like to know which line number I'm on. And in the end, this might not even be right, so this might run for like an hour or something and then give me the wrong answer. Well, I forgot to increment that. I did a permutation of symbols. Yeah, I'm working with combinations instead of permutations. So I think there should be fewer there should be fewer combinations than permutations, but maybe you have like a clever way of ruling out invalid permutations before you do too much work. I'm not very clever. I'm checking every permutation with the right total number of hashes, because from these numbers at the end, you know the total number of hashes in the string. So I'm only checking strings with that number of hashes, and then I check to see if they have the right grouping. I want to keep an eye on my memory. Okay, I don't seem to have any debilitating memory leaks. Maybe it's going up slightly, but for like days 6 through 10 or 6 through 9 or something, I was having trouble with every day. I would consume all of my memory and then basically crash my Twitch stream. So that doesn't seem to be happening today, at least. Line 74. Yeah, this is not very fast. I don't know when I started this. But I think it's been less than 5 minutes, so this should almost certainly finish in less than an hour. Some strings are longer than others. The worst case scenario is if half of the question marks are hashes, because that's going to have the largest number of permutations. Like that's just the way that combinations work. If you look at Pascal's triangle, and choose K. I had this open before. Yeah, basically, the left side of Pascal's triangle is the case where like none of the question marks are hashes, so you only have one combination to check. They're all dots. The right side of Pascal's triangle is the case where all of the question marks are hashes. So again, you only have one case to check. The worst case scenario is in the middle. That's where you get these large numbers of combinations, and that's when half of the question marks are hashes. So some lines take longer than others to check all those combinations, and I'm doing this by splitting the strings and looking at the lengths of the groups, so it's not really very efficient to begin with. Yeah, I'm generating pretty much every possible assignment of hash or dot for each question mark. Like maybe I can explain that a little bit better. So like if you have 3 question marks, they also give you numbers at the end. So they say 2, and basically 2 means they don't give this to you directly, but you can figure out the total number of hashes. So let's say this is our input, then the combinations that I check are hash hash dot, hash dot hash, and dot hash hash. So I check those 3, but I don't check, I do not check dot dot hash because that only has 1 hash, and I know it doesn't match that criteria that I'm given. So I just generate these procedurally, but I skip these. So like I don't have to waste time on doing something like this or something with 3 hashes, because I also know that that's not even a possibility to begin with. So I generate all these, and then I check if they satisfy the grouping criteria. So like then I would say that this is valid because there's a group of 2, and this is valid because there's a group of 2, but this one, I generate it and I check it and I find that it's invalid. So yeah, there should be a more clever way where you can not even generate this to begin with, but I don't know if I'm clever enough for that. No, it's not 2 to the n. So I'm not checking this. So if you think of this like a binary number where you have like zeros or ones, then that would be 2 to the n, right? Because this is a binary number. So 2 to the 3 would be 8. I don't know if I want to spell all of these out, but yeah, so this is 8, right? 8 lines selected. I'm not checking all of these. I'm only checking things with the correct number of hashes. So it's not 2 to the n, it's n choose k. And the mathematical expression for that is kind of complicated. It's a bunch of factorials, like it's n factorial over k factorial times n minus k factorial. So it's Pascal's triangle. Oh, by the way, welcome to the stream. Haha, you are so funny. I built a function to have the next lexicographic permutation. Yeah, I looked that up. It's the next lexicographic combination. Combinations are different from permutations. So with permutations, the order matters. With combinations, the order doesn't matter. So I looked this up, and I'm generating all of these and then checking which ones have valid groupings. We're almost halfway done on line 400 out of 1,000. I don't know why I switched to zeros and ones, dots, and combinations were totally. You're from Italy. Cool. Are you in Italy right now? It must be really late. So, yeah. How do I explain that? So, it's 3 a.m. Well, that's pretty late. You don't generate the string. You generate an index array. So you generate 0, 1. So this is the string that we want to generate, but to not brute force this and not do 2 to the n, we generate an index array of length 2. So we have 0, 1, 0, 2, and 1, 2. And now these index arrays represent these strings. So they give you the positions of the hashes in these strings. And like the maximum value here is 2 because it's 1 minus the length of the string because I'm using 0-based arrays. And then yeah, the order doesn't matter, so I can have 1, 2, but I don't have 2, 1. And that's the difference between a permutation and a combination. So this thing is never generated and checked. And I wasn't clever enough to come up with that myself. I just Googled this last night when I saw the problem description. I Googled like how to generate combinations, and I found this code, which I spent like the first hour of this stream trying to figure out how to translate because I kept doing something wrong. My language is interpreted. I would make a compiler if I could, but it's just too much work. I think it's easier to make interpreted languages. Yeah, I am definitely not going to do part 2 tonight. Once this finishes, I'm done. With multiple contiguous groups, yeah. So we'll need something bigger. Is it like Python? It's kind of like Python. It looks more like JavaScript because I use curly braces. So JavaScript has curly braces, Python just has indentation. So in this sense, it looks a little bit more like JavaScript. It also looks a little bit like Rust because of the keywords that I use. So like I use fn for function. That comes from Rust. Rust calls functions fn. And then the type names are i32 for 32-bit integers and i64 for 64-bit integers. Yeah, let's work through an example for multiple contiguous groups. So let me just get some more space. Let's say they give you this, and yeah, Python is interpreted. Yeah, that's right. Let's say they give us 5 question marks and a group of 2 and a group of 2. So we know that there have to be 4 total hashes. And then my lang is more readable. Well, that's... I'm glad you think so, but that's your opinion. Some people might think other languages are more readable. Rust is like very short, very terse, like just fn for function, only 2 letters. That's, yeah, well, that's just like your opinion, man. So I like that. I tend to use really short variable names. I know it's not for everybody. Welcome to the stream, Jordan Lido. So for groups of 2 and groups of 2, our index array would be like 0, 1, 2, 3. That would be the first combination, but we could go up to 4 because there's this last character. So then all of the permutations, so this could be 4, or this could be 3, or this could be 2, or this could be 1. So this is the whole index array, and then which strings do these generate? Remember, these are the positions of the hashes. So these would generate the strings hash, 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 dot, hash, 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 dot, hash. Basically, you can think of this like all we're changing is the position of the dot instead of the position of the hashes. So there aren't that many combinations. And then the last one is that. So for this input, these are all the strings that I generate. You can probably do it a smarter way and not generate that many. And then this is the only valid one because it has 2 groups of 2. 80% done. Yeah, 86% done. And when this finishes, I'm going to paste in the number to advent of code. And if it's right, good. I'm done for the night. And if it's wrong, I'm still done for the night. I'm not going to sit around and debug this anymore. This line is taking a while. We're getting there. There must be a faster way to do this. I think they say on AOC that any problem can be solved in like 10 seconds on decade-old hardware. How would it look for that same example, but for groups 2, 1? That's worse because there are more permutations there, but we can start to work through it at least. So if it's 2, 1, well, now we know that there are 3 hashes. So our index array is only going to be of length 3. And then it could be that. This could be a 3. This could go all the way up to 4. Then we can't make this any higher than 4. So the next combination is going to be not that, 2 there. And then 2, 4. And then 3, 4. And then 1, 2. Is that everything? I might have missed one. Oh, okay, this is done. Yeah, maybe I won't finish working through that. Fingers crossed. Oh man, we got lucky. I'll at least read part 2. I don't think I can do this. How long did that take? That took 15 minutes. So I need to optimize this before I can do part 2. Five copies of itself separated by an extra question mark. What? Oh, so both things get repeated. Okay, so this gets repeated 5 times with an extra question mark. And then the 1 also gets repeated. Yeah, I can't do that because it's going to take at least 5 times longer, and it's probably exponential. So it's probably impossible for me to run in any reasonable amount of time. Yeah, I might just have to cut my losses on this problem. Well, I'll at least commit what I have so far. Now I know why you have no power to solve part 2. Yeah, I'm right there with you. I think I was a little bit clever. Like I didn't check everything 2 to the n. I checked only the combinations with the right number of hashes. But now I need to be even more clever and somehow, like, not even generate this, just generate this immediately, if that's possible. There has to be some optimization that I can't think of, because yeah, 15 minutes is way too long. Okay, did I push? Maybe over the weekend I'll come back to this and work on it, but odds are Wednesday or Thursday or Friday there's going to be some other difficult problem, so I'm just never going to catch up. I'm going to have problems that I can't solve. I'm an emo, but a positive ohm. Is that a palindrome? I do not have a private leaderboard. I'm on somebody else's private leaderboard, but I don't have my own. I think next year I'll make one. I'm also on just shit posting. Yeah, that's fine. Shit posting is legal here. There's this YouTuber, William Fung. I think that's his name. Yeah, William Fung. He has YouTube solutions of every day, I think. As far as I know, he always solves them. So I'm on this leaderboard. I think you can find him.
Hi everyone, in this video we're going to be doing day 2 of additive.
He probably has a link to his leaderboard in the description. Code, puzzles, huh. Maybe he doesn't link his leaderboard. Maybe it's on his GitHub. This is his leaderboard from last year, so maybe he didn't. Yeah, I don't know. Anyway, do I like banter? I usually do, but I'm probably going to end the stream imminently. What about philosophy? I like philosophy. My brain is so empty from Advent of Code that I probably couldn't name any philosophers if you asked me to. Asceticism. I might need to be reminded of what exactly asceticism is. Isn't that like when you deny yourself all pleasures, like no food, or just the minimal amount of food that you can get by on to survive? Yeah, that sounds extreme. Didn't Buddha decide that asceticism was too extreme and decadence was the opposite extreme and the middle path is the right way to live? I think I agree with the Buddha on that one. The middle path is the way to go. Yeah, so this is the code that we struggled through for part 1. There's got to be some kind of optimization. I don't know how else to solve part 2. I can't let this run for hours and hours. The Tau. The Tau is the way. All right, yeah. I think I'm going to end the stream. So thanks everybody for tuning in, and I will catch you next time.